AP Physics, page 53, problem number 7. Here we have a speed versus time graph. It's not a velocity versus time graph, so we cannot specifically deduce the acceleration from this graph. If it were a velocity graph, then the slope at any point would be the acceleration. If it were a displacement graph, the slope at any point would be the velocity, but this is just strictly a speed graph. So we can determine a few things from the graph, though, but we're going to be using this equation right here if I circle this, where in context here, the V stands for speed, the average speed, which at most points in this graph is changing, but there's a few spots, as you'll see in part C, where there's a constant speed. So the V here stands for the average speed. At any specific spot, it's the instantaneous speed at that spot. And the D here stands for the distance traveled. Now in part A, it says how far has it traveled during the third second. Not at time 3. Time 3 would be a specific point in time, but the third second would be from the time period from the 2.0 to the 3.0 time frame. That would be the third second, so I have that indicated up here. And during that time, there was a constant speed of 2 meters per second. Times the time period, time interval, which is 1 second, so it simply goes 2 meters in that time period, that time span. The maximum speed you can see is the 4 meters per second in the time period from 4 to 5 seconds. The minimum speed, it starts off at 0 meters per second and ends at 0 meters per second at the 0 and the 7-second mark. And there's a constant speed, actually probably starting a little bit before the 2-second mark, slightly before the 2-second mark, and a little bit after the 2-second mark. I probably should have put like about 1.8 here to be more accurate. Could have done a little better there. To about 3.3 or 3.4 seconds, constant speed. And this is pretty accurate here for the second frame or second interval of constant speed, the 4 meters per second from 4 to 5 seconds.